I'll begin with my today's talk, which is artificial intelligence and machine learning. Okay, so artificial intelligence, often defined as the simulation of human intelligence in machine, has rapidly established its presence as a pivotal and transformative force in numerous research domains. As I'm scientist, so I would uh, throw some light from the research perspective. So, in this lecture, we will explore the expansive applications of AI in research because in internet there are a lot of information and theoretical data is available. So we will focus on the application or implication point, emphasizing its profound impact on scientific discovery, data analysis, and problem solving. So researchers have harnessed the power of AI to augment their capabilities, streamline the process of data analysis, and unveil insights that were once beyond their reach. The inception of AI marked a new era in the ability to mimic and replicate cognitive processes, a feat that has been particularly advantageous to the research community. So, as researchers endeavor to advance knowledge and innovation in their respective fields, AI, artificial intelligence, has become an indispensable tool in their arsenal. It empowers them to navigate the complexities of their work with greater efficiency and efficacy. So this talk serves as a guide to the diverse applications of AI in research, highlighting its adaptability across a multitude of domains, whether it is the application of machine learning to dissect vast data sets or natural language processing to glean insights from extensive textual sources. AI has become an invaluable ally in the pursuit of knowledge. So the journey begins with an exploration of the AI powered technologies that underpin the research applications and the intricacies of machine learning, natural language processing, computer vision, and robotics, each with its unique set of contributions to the research landscape. Furthermore, I would like to explore with you all the pivotal role of AI in scientific discovery. So, researchers across the spectrum, from pharmaceutical companies to climate scientists and particle physicists, are leveraging this AI to expedite the process of drug discovery, model climate change, and analyze particle physics data, among other applications. AI serves as a catalyst for innovation in these fields, enabling researchers to address critical global challenges. So it also highlights AI's role in data analysis and visualization. In fields such as economics, social science, and genomics, the ability of AI to uncover hidden insights and correlations within vast data sets has become a game changer. And additionally, AI powered data visualization tools make it more accessible for researchers to interpret and present complex information, facilitating a deeper understanding of research findings. So, beyond data analysis, AI also contributes significantly to problem solving and optimization. So, researchers can rely on AI to address complex optimization problems in logistics, transportation, and resource allocations. The technology assists in finding the most efficient and cost-effective solutions, further streamlining research processes and decision making. However, the integration of AI into research is not without its challenges and ethical considerations. So, issues like bias, AI algorithms, data privacy, and the responsible use of AI necessitate careful consideration. So researchers and the research community must be conscious of these challenges and work to address them in their pursuit of knowledge. So artificial intelligence has emerged as a driving force, redefining the way research is conducted and expanding the horizons of what is possible. As technology continues to advance, AI's roles in research or any other field is poised to grow, promoting to further unlock the frontiers of knowledge. So, to ensure its responsible and equitable use in research application, it is imperative for researchers to address the challenges and ethical considerations associated with AI, and thus forging a path toward a future where AI and research are inextricably intertwined. Next slide, please. Now, this is about the foundations of artificial intelligence, because many of the participants they are new to this AI. That's why I would take pleasure to simplify this. So let's start by understanding the basics of artificial intelligence (AI). So AI is a tool technology that helps machines think and learn like humans. It works through creating spatial rules, which we call algorithms, and computer programs that make machines smart. Inside AI, there is a special part called machine learning. It's like the brain of artificial intelligence, allowing machines to learn and get better without someone telling them exactly what to do. So together, these technologies are like the building blocks that make AI useful in research. They are the foundation on which we can do amazing things with AI in different research areas or in different domains. Okay, let's break down the basics of artificial intelligence. Imagine AI as a super cool technology that makes machines smart, helping them think and learn similar to how humans do. Now, how does it do that? Well, AI has these sets of spatial rules known as I discussed earlier, algorithms, and it uses computer programs to follow these rules. So it's like giving instructions to machine to make them clever. Inside AI, there is something even more interesting called machine learning. So think of it as the brain of AI. With machine learning, machines can learn on their own and get better at tasks without someone explicitly telling them every step. So it's like when you practice a riddle or when you practice riding a bike, and you get better over time without someone constantly telling you what to do. So now, why is all of this important? So these technologies, the algorithms and machine learning, are like the building blocks, the foundation that makes AI really useful in many fields. So there are the tools that help us to do incredible things with AI across different areas of research. So imagine you have a smart friend who can learn and figure things uh, out on their own, similar to how you learn from experiences. So that's what artificial intelligence tries to make machines do: be smart and learn without us having to explain every little detail. Now, the algorithms. To make machines smart, we use something like a set of spatial rules called algorithms. So these are like step-by-step instructions that tell the machine what to do. For example, if you want a machine to recognize pictures of cats or dog, we create an algorithm that teaches it what features to look for, like pointy ears or furry tail. Then computer programs. So now, to make these rules work, we use computer programs. So these programs are like the tools that apply the spatial rules algorithms to different situations. So if the algorithm is the recipe, the computer program is the chef following the steps to make the dish, or in this case, make the machine smart. Then machine learning, the brain of AI, as I discussed earlier. Inside AI, there is a fascinating part called machine learning. It's like the brain of artificial intelligence. Just like how you get better at a game or a skill by practicing, machine this AML, we call machine learning, allows machine to get better at tasks by practicing on their own. So you show the machine lots of example, and it learns to improve its performance over time. Now, what are building blocks for research? Now, why is all this important? In research, think of these technologies. As I know that there are lots of engineers, that's why I'm discussing this algorithms and machine learning as the building blocks. They are the tools that scientists, researchers use to analyze huge amounts of data, find patterns, and make sense of complex information. So it's like having a super smart assistant that can go through mountains of data much faster than humans can. And in a nutshell, this particular foundation of AI, the algorithms and machine learning empower machines to be smart and learn, making them invaluable tools for researchers across different fields. So they help us unlock new insights, discover patterns, and ultimately push the boundaries of what we can understand and achieve. Next slide, please. Okay, now enhancing data analysis. One of the primary contributions of AI in research is its ability to analyze vast amounts of data with unprecedented speed and accuracy. So traditional research methods often grapple with data overload, making it challenging to extract meaningful insights. So AI algorithms, particularly those based on deep learning, excel at pattern recognition and can uncover hidden correlations with massive data sets. So this capacity has transformed fields such as genomics, climate science, and social sciences, enabling researchers to derive meaningful conclusions from complex data structures. Now let's dig into how AI is like a superhero when it comes to analyzing loads of data in research. The first one is handling massive data. So in research, there is often a ton of data to deal with, as you are aware, so much that it can feel like trying to find a needle in a haystack. So this is where AI steps in as a champion. It has this fantastic ability to handle enormous amounts of data at lightning speed, something traditional methods struggle with. Then speed and accuracy. So AI can sift through mountains of data in a fraction of the time it would take a human, and not just that, it does it with incredible precision also. It's like having a super fast and ultra precise assistant that helps researchers make sense of the overwhelming amount of information they have. Then breaking down complex data structures. So research often involves dealing with intricate and complex data structures. So AI, especially using a technique called deep learning, is like a master detective that excels at recognizing patterns and uncovering hidden connections within these massive data sets. It's like finding the missing puzzle pieces to complete the picture. Then the next is transforming various fields. So AI's talent for handling data has revolutionized different areas of research. In genomics, it helps decode and understand the complex genetic information. In climate science, it processes vast amounts of data to model and predict climate patterns. Even in social sciences, it aids in making sense of intricate social interactions. So essentially, it is like a universal tool that researchers can use to draw meaningful conclusions from data that would otherwise be overwhelming. Then comes data overload challenges. So in many research endeavors, there is a flood of data to wade through. So traditional methods might struggle with the sheer volume, leading to delays and potential oversights. So AI steps in as a solution to this challenge, efficiently managing and processing massive data sets that would otherwise be impractical for humans to handle in a reasonable time frame. Then the next is unprecedented speed and precision. Yes, AI operates at an impressive speed, swiftly navigating through vast amounts of information. It's like having a research assistant with super hero speed, the kind that can the kind that can analyze thousands of data points in seconds. So not only is it fast, but it is also incredibly precise. The risk of human error is significantly reduced, ensuring that the analysis is thorough and accurate. Then pattern recognition with deep learning. So AI, especially through a technique known as deep learning, mimics the human's brain ability to recognize patterns. So in complex data sets, there are often hidden relationships and trends that might go unnoticed by traditional methods. So AI's deep learning algorithms excel at uncovering these patterns, providing researchers with valuable insights that might have otherwise remained elusive. Then genomic advancements. Consider genomics where researchers explore the vast genetic information within organism. So AI is instrumental in deciphering the complexities of genomes, identifying genetic matters, and even predicting potential health outcomes. So this not only expedites the research process, but also opens up new possibilities for personalized medicine and targeted treatments. Then climate science predictions. So in climate science, AI is a game changer. Climate data is extensive, and dynamic, covering a range of variables. So AI models can process this information, discern pattern in temperature changes, precipitation, and atmospheric conditions, contributing to more accurate climate predictions. So this is crucial for understanding and mitigating the impact of climate change. And the last is social sciences insights. Even in social sciences, where understanding human behavior and interactions is a key, AI can assist in making sense of intricate social structures, analyzing social media data, for instance, can reveal patterns in public sentiment or behavior, providing researchers with valuable insights into societal trends and attitudes. So AI abilities to handle data to scale, coupled with its speed, precision, and pattern recognition capabilities, transforms the landscapes of research. Whether it is decoding genetic information, predicting climate patterns, or understanding complex social dynamics, AI emerges as a powerful ally, helping researchers derive meaningful conclusions from the vast sea of data available to them. So, in a nutshell, of this slide, AI is like a data superhero. It tackles the overwhelming amounts of information in research with incredible speed, accuracy, and the ability to uncover hidden connections. So this superhero has significantly impacted various fields, making it an indispensable ally for researchers navigating the complexities of what you can say data analysis. Next slide, please. Next is automation of repetitive tasks. So, AI's proficiency in automating repetitive and time-consuming tasks has liberated researchers to focus on more creative and complex aspects of their work. So, routine tasks like data pre-processing, literature reviews, and experiment execution can be streamlined through AI-driven information, allowing all the engineers and researchers to allocate their time and energy to higher order what you can say thinking and problem solving. So the first is relief from repetition. So imagine having to do the same task over and over again, like sorting through heaps of data or reviewing stacks of research papers. So this repetitive task, though crucial, can be time consuming and let's face it, a bit dull. So AI comes to the rescue by taking over these repetitive duties, offering researchers a break from the monotony. Then the next is time and efficiency gains. So AI's strength lies in its ability to perform tasks at incredible speed and accuracy, as we discussed earlier also, when applied to routine jobs like data preprocessing, which involves cleaning, organizing, and preparing data for analysis. This AI can do the job in a fraction of the time it would take a human. So this not only saves time, but also ensures that the process is done consistently and without errors. Then streamlining literature reviews. For researchers, as you all aware, literature review is the most important method or what you can say step. So drowning in a sea of academic papers during literature review, AI can be a lifesaver. It can swiftly scan through an extensive database of articles, extracting relevant information and summarizing key findings. This is very important. So this significantly speeds up the literature review process, allowing researchers to focus more on understanding the content rather than spending endless hours on the initial scanning. Then experiment execution assistance. So in a laboratory setting, conducting experiments can be both time consuming and resource intensive. So AI can be integrated to handle the execution of certain types of experiments, especially those that involve repetitive procedures. So this not only ensures precision, but also frees up researchers to focus on the design of experiments, analysis of results, and the overall scientific strategy. Then the next point is empowering higher order thinking. So by automating repetitive tasks, AI liberates researchers to engage in more creative and intellectually demanding aspects of their work. So instead of spending hours on data entry or literature scanning, researchers can channel their energy into critical thinking, problem solving, logical reasoning, and the development of innovative research questions. And then comes my favorite innovation. The ability to delegate routine tasks to AI opens up avenues for innovation. Researchers can invest their time in exploring new technologies, designing novel experiments, and pushing the boundaries of their fields. So this shift from mundane tasks to more intellectually stimulating work can lead to breakthroughs and advancements that may not have been possible without AI assistance. Then, of course, precision and consistency. When researchers deal with repetitive tasks manually, there is always a risk of human error. Now, AI, on the other hand, operates with precision and consistency, whether it is data pre-processing, literature review, or experiment execution. AI ensures that tasks are performed accurately every time. This reliability is crucial for maintaining the integrity of research outcomes. Then comes scalability. So as the scale of research projects grows, so does the volume of repetitive tasks. So AI excel in scalability. It can handle large data sets, process extensive literature databases, and execute repetitive experiments on a scale that would be impractical for humans. So this scalability allows researchers to tackle ambitious projects that might otherwise be overwhelming. Then continuous learning and adaptation. So AI systems can learn from the task they perform. So this means that as researchers engage AI in their work, the system learns from the data it processes and the patterns it identifies. So over time, this continuous learning can lead to improved efficiency and effectiveness in handling specific tasks, adapting to the evolving needs of the research process. Then human machine collaboration. So while AI takes care of repetitive tasks, it also fosters a collaborative environment between humans and machines. So researchers can leverage AI as a powerful tool, combining their expertise with the computational capabilities of AI. And this collaboration enhances the overall research process, with AI acting as a supportive partner rather than a replacement for human intelligence. This is very important that we created AI. So always remember. And then resource optimization. So research often involves limited resources, including time and the most importantly, funding. So by automating repetitive tasks, researchers can optimize or engineers can optimize these resources. So time-consuming tasks that once required a significant portion of the researchers or engineers' schedules can now be accomplished efficiently, allowing for a more judicious allocation of time to tasks that require human intellect and creativity. Then innovation in research design. With the burden of repetitive tasks lifted, researchers are afforded the freedom to innovate in their research designs. So they can explore new methodologies, devise unconventional experiments, and explore interdisciplinary approaches. So AI, by handling the routine, becomes an enabler of innovation, encouraging researchers to think beyond the conventional and push the boundaries of their respective fields. Then comes reducing burnout and enhancing well-being. So researchers often face the pressure of deadlines and the stress associated with tedious tasks. By offloading repetitive work to AI, these engineers can experience reduced burnout and improve well-being. So this in turn contribute to a healthier and more sustainable research environment. It gives longevity and a dedication to the pursuit of knowledge. So AI's proficiency overall in automating repetitive tasks is not just about making things easier. It's about empowering researchers to be more efficient, creative, and most importantly, innovative. So by freeing them from the burden of monotonous cars, AI allows researchers to focus on the exciting and challenging aspects of their work, ultimately contributing to the advancement of knowledge and scientific discovery. So the automation of repetitive tasks by AI is not just a convenience, it's a transformative force in the research landscape. It brings precision, scalability, continuous learning, and the potential for groundbreaking collaboration between humans and machines. By liberating researchers from mundane tasks, AI opens door for innovation, resource optimization, and improved well-being in the pursuit of scientific discovery. Next slide, please. Accelerating drug discovery and healthcare research. So, in the realm of healthcare and life sciences, AI has emerged as a game changer. Drug discovery, historically arduous and time-consuming process, is now expedited through AI-driven virtual screening, target identification, and molecular modeling. Additionally, AI plays a crucial role in analyzing medical images, diagnosing diseases, and predicting uh, patient outcomes, enhancing the efficiency and accuracy of healthcare research. And we all have experienced this during during the COVID era, that the scientists, they have reduce the discovery time of the drug, and they within a very short and stipulated time, they invented a vaccine, COVID vaccine. So now let's explore how AI is revolutionizing the world of healthcare and life sciences, making significant strides in drug discovery and various aspects of medical research. So the first historical challenges in discovery. So discovering new drugs has traditionally been a slow and challenging process. Sometimes it takes 10 years also to completely invent and implement the particular drug. So it involves screening countless chemical compounds, identifying potential targets, and understanding their effects on biological systems. So this process is not only time consuming, but also comes with a high likelihood of failure at various stages. So AI driven virtual screening. Now, AI steps in as a game changer in this drug discovery area. Through a technique known as virtual screening, AI algorithms analyze massive databases of chemical compounds, and this virtual screening helps identify potential drug candidates with characteristics that match the desired properties of for treating a specific disease. So AI significantly expedites the initial stage, or you can say initial stages of drug discovery, by narrowing down the pool of potential compounds for further investigation. Then comes target identification, molecular modeling. So identifying the right target in the body for potential drug is a critical stage, usually. So AI excels in this area by analyzing biological data to pinpoint specific targets associated with diseases. Moreover, AI contributes to molecular modeling, simulating how potential drugs interact with biological structures at the molecular level. So this helps the researchers predict the effectiveness and safety of drug candidates before even stepping into a laboratory. Then efficient analysis and medical images. So AI rather capabilities extend beyond drug discovery into the realm of medical imaging. So in healthcare research, AI is harnessed to analyze complex medical images such as X-rays, MRIs, and CT scans. So AI algorithms can quickly and accurately identify anomalies or patterns indicative of diseases. So this not only expedites the diagnostic process, but also enhances the precision of identifying and understanding medical conditions. Okay. Then comes disease diagnosis and prediction. So AI has proven to be valuable ally in diagnosing diseases by analyzing diverse data sets, including patient records, genetic information, and medical images. AI can assist in early disease detection. So moreover, predictive modeling using AI allows researchers to anticipate patient outcomes based on various factors, aiding in treatment, planning, and personalized medicine. Then enhancing efficiency and accuracy. So the integration of AI in healthcare research brings unparalleled efficiency and accuracy. Tasks that once required extensive manual effort, such as sifting through vast database or analyzing intricate medical images, can now be performed swiftly and with a high degree of precision. So this not only saves again time, but also minimizes the risk of human error, particularly in tasks demanding meticulous attention. Now, unlocking new therapeutic possibilities. So, the speed of efficiency AI introduces to drug discovery and healthcare research open doors to exploring a wide range of potential treatments. So, researchers can now examine a more extensive array of drug candidates and therapeutic approaches, so leading to the discovery of innovative solutions for diseases that have historically posed significant challenges. So AI's impact in healthcare and life sciences is transformative, from accelerating drug discovery through virtual screening to revolutionizing medical imaging analysis and disease diagnosis. AI is reshaping the landscape of healthcare research. And the synergy between human expertise and AI capabilities holds the promise of unlocking new therapeutic possibilities and improving healthcare outcomes for individuals worldwide. Now, these AI powered technologies in machine learning. Um, Yes. So now machine learning is a fundamental subset of artificial intelligence that has opened up new dimensions in research across various domains. So researchers have harnessed the power of machine learning algorithms such as neural networks and decision trees to extract valuable insights from extensive data sets, revolutionizing the research process. This particularly, we will explore the applications and impacts of machine learning in different fields. So uncovering patterns and trends, machine learning algorithms excel at recognizing complex patterns and trends in vast database. So in healthcare, for instance, researchers can employ these algorithms to analyze patient records, as we discussed earlier, also medical imaging and genomics data. So by doing so, they can identify disease patterns, predict patient outcomes, and develop personalized treatment plans. So in finance, also machine learning is pivotal for detecting fraudulent transactions and predicting market trends, enabling more accurate investment decisions. Uncovering patterns and trends with machine learning. Machine learning algorithms have demonstrated remarkable proficiency in uncovering complex patterns and trends within extensive data sets, a capability that has had profound implications across various research domains. So two striking examples of this capacity are found in the realm of healthcare and finance, where machine learning is fundamentally transforming the research landscape. Now, there are the healthcare applications of the machine learning, like disease pattern identification. So in healthcare research, machine learning has become an indispensable tool for identifying disease patterns. So it can process vast amounts of patient records, enabling researchers to spot hidden correlations and trends within the data. So this is particularly valuable in epidemiology, as it allows for the early detection of disease outbreaks and the identification of factors contributing to the spread of diseases. Then patient outcome prediction. Now, machine learning algorithms are employed to predict patient outcomes with a high degree of accuracy. So by analyzing patient data such as medical histories, test results, and treatment responses, researchers can forecast, or technicians can forecast rather, patient-specific outcomes, and this can assist healthcare providers in tailoring treatment plans to individual patients, improving patient care, and potentially it saves lives. Then personalized treatment plans. So machine learning plays a pivotal role in personalized medicine. By analyzing genomic data, it can identify genetic variation and biomarkers associated with specific diseases. So this information is crucial for tailoring treatment plans and developing targeted therapies, which are not only more effective, but also reduce the risk of adverse side effects. Then financial applications. So the first is fraud detection. So machine learning is a cornerstone of fraud detection in the financial sector. It can analyze transaction data in real time, flagging unusual patterns and anomalies that might indicate fraudulent activity. So this not only protects financial institutions from losses, but also safeguards the interest of customer. Then market trend prediction. Now, machine learning models are used to analyze historical market data and identify trends, so enabling investors and traders to make more informed decisions. So these models can also factor in a wide range of data sources, including news sentiments, analysis, and social media trends to predict market movements accurately. So, in both, we discuss healthcare and finance. Machine learning provides a distinct advantage by sifting through the vast and complex data sets that are inherent to these fields. So, the ability to discern intricate patterns and trends not only enhances the accuracy of predictions but also fosters a deeper understanding of the underlying mechanisms driving phenomena, whether they be health related outcomes or market behavior. So, by harnessing the capabilities of machine learning, researchers in these domains can make data driven decisions, resulting in more effective treatments, better patient outcomes, reduce financial risk, and informed investment strategies. So, the practical implications extend beyond individual research projects, impacting the quality of healthcare services and the stability of financial systems, illustrating the transformative potential of AI in the research field. Then comes predictive modeling. So researchers in diverse fields turn into machine learning for predictive modeling. For example, epidemiologists use it to model disease spread and assesses the impact of public health interventions. So economists also use it to forecast economic indicators, aiding in policy decision making. The ability to make accurate predictions is very instrumental in understanding and preparing for future scenarios. So predictive modeling with machine learning. Now, predictive modeling, a key application of machine learning. This usually empowers researchers across diverse fields to make informed decisions by forecasting future scenarios based on historical data and patterns. So it is a critical tool for researchers in areas such as epidemiology and economics, where understanding and preparing for future outcomes are of paramount importance. Next slide, please. Sorry, the previous slide. Epidemiology. Yes, epidemiology. So this is spread modeling. So now these epidemiologists use predictive modeling to simulate the spread of diseases by analyzing data on vast outbreaks, population movements, and other relevant factors. So machine learning algorithms can generate models that forecast how a disease is likely to propagate. So these models assist in resource allocation, allowing public health officials to deploy interventions effectively and control the spread of diseases. So impact assessment of public health interventions, when public health interventions such as vaccination campaigns or social distancing measures, we experience this all, are implemented, predictive modeling can assess their impact. So researchers can use machine learning to project the outcomes of various intervention strategies, allowing policymakers to make informed decisions regarding the allocation of resources and the timing of interventions. Then comes economics. So economic indicator forecasting. Now, economists rely on predictive modeling to forecast economic indicators such as GDP growth, inflation rates, and employment trends. So machine learning algorithms analyze historical economic data along with a wide range of variables such as trade data, political events, and consumer sentiment to make accurate predictions. So these forecasts are crucial for policymakers and businesses to make decisions regarding investment, monetary policy, and financial planning. Then comes policy decision making. So predictive modeling in economics aids in policy decision making. For example, it can help governments plan for fiscal stimulus measures during economic downturns or assesses the impact of changes in interest rates. So the ability to predict the consequences of policy decisions is invaluable for creating effective strategies to manage economic challenges and promote stability. So in both epidemiologies and economics, the power of predictive modeling lies in its ability to anticipate future development. So researchers can use machine learning to test various scenarios, identify potential risks, and evaluate the effectiveness of interventions or policies. So this forward-looking approach enables a more proactive response to complex challenges and uncertainties. So the integration of machine learning in predictive modeling not only enhances the accuracy of forecasts, but also streamlines the research process. So it allows researchers, engineers, technicians to process large data sets efficiently, adapt models in real time, and make data-driven decisions. As machine learning technology continues to advance, its predictive modeling capabilities are expected to play an increasingly very important role in research across various fields, providing valuable insights and tools for evidence-based decision making. Then comes data classification. In social sciences and beyond, data classification plays a crucial role in research. So machine learning algorithms can classify data into relevant categories, helping researchers quickly identify and analyze key information. So in sociology, for example, text classification models can be used to categorize social media posts, news articles, or surveys into various themes, so making it easier to extract meaningful insights from a large volume of unstructured data. Then data classification with machine learning. Now, data classification, a fundamental function of machine learning, is instrumental in numerous research areas, including social sciences. So researchers turn to machine learning algorithms to categorize data into relevant and meaningful categories, greatly aiding in the process of identifying and analyzing key information. So in social sciences, the capability is particularly useful, enabling researchers to sift through a large, what you can say, volumes of unstructured data and extract valuable insights efficiently. And then the applications in social sciences. Now, the first application is text classification. So in sociology, one of the main applications of data classification is in the categorization of textual data. So this includes social media posts, news articles, surveys, and other textual content. So text classification models can be designed to assign documents to various thematic categories. For example, researchers may want to categorize social media posts into themes like political discourse, public sentiment, or health-related discussions. By doing so, they can quickly identify emerging trends, sentiments, or key issues within the data. Then sentiment analysis, also one of the application, like data classification also extends to sentiment analysis, which is a pivotal in understanding public sentiment and opinion. So in the social sciences, researchers employ machine learning to classify text data into categories such as positive, negative, or neutral sentiment. And this information can help sociologists gain insights into public perception. They can track changes in sentiment over time and correlate sentiment with events or policy changes. Then also in news article categorization, sociological research often involves the analysis of news articles to understand media coverage and its impact on public discourse. So machine learning models can be used to categorize news articles by topic, allowing researchers to focus on specific subjects of interest. So this aids in studying media bias, agenda setting, and the framing of public issues. So the significance of data classification in social sciences in its ability to automate a process that would be highly labor intensive and time consuming if done manually. By classifying data into relevant categories, researchers can efficiently extract information that is pertinent to their research questions, identify trends, and draw meaningful conclusions from extensive and diverse data sets. So machine learning models, when trained on labeled data, can learn to recognize patterns and characteristics associated with different categories, enabling them to classify new unseen data accurately. So this information or automation not only accelerates the research process, but also reduces the potential for human bias and error in data classification, ensuring the reliability of the research findings in the evolving landscape of social sciences. Data classification with machine learning. And also the machine learning is, becoming an indispensable tool for researchers aiming to make a sense of vast and diverse source of information. Then process optimization. Machine learning also contributes to optimizing various research processes in manufacturing and supply chain research. For example, machine learning is used to enhance production processes, reduce waste, and minimize downtime through predictive maintenance. So these applications not only improve efficiency but also lower operational costs, contributing to overall research productivity. Now, process optimization with machine learning. Now, machine learning, as I said earlier, also is a powerful tool that extends its reach to process optimization. So a critical facet of research across various fields, including manufacturing and supply chain management. So the application of machine learning in this context has far-reaching implications, as it not only enhances operational efficiency, but also substantially reduces operational cost, thereby contributing to increased research productivity. Now, the applications in process optimization. The first is manufacturing. So in manufacturing, process optimization is vital for increasing production efficiency, product quality. Machine learning algorithms can be employed to monitor and control various aspects of manufacturing process in real time. For example, in the automotive industry, machine learning is used to optimize robotic assembly and what you can say, or robotic assembly lines, ensuring that the right parts are assembled correctly, reducing defects and improving production speed. Predictive maintenance. Predictive maintenance is an essential application of machine learning in manufacturing and many other domains. So machine learning models are trained to predict equipment failures or maintenance needs based on data from sensors and historical maintenance records. So by predicting when machinery is likely to fail, companies can perform maintenance at the optimal time, minimizing costly downtime and reducing the need for reactive maintenance. Then supply chain management. Just a minute, I have another lecture and they're calling me, so I'll just inform. Okay, supply chain management. So machine learning is applied to optimize supply chain processes. Algorithms can analyze historical data, current demand, and external factors such as weather and transportation conditions to make accurate predictions regarding inventory levels, order quantities, and delivery schedules. So this ensures that supply chain operations are efficient and responsive to market demands. Then energy efficiency also. So process optimization extends to energy management. Machine learning models can analyze energy consumption patterns in industrial settings and identify opportunities for energy efficiency improvements. So this is crucial in research related to sustainability and environmental impact reduction. So the significance of process optimization with machine learning is twofold. First, it enhances operational efficiency by reducing waste, minimizing downtime, and improving the quality of products and services. And in manufacturing, for example, this can lead to a higher production rates, reduce defects, and better resource utilization. Second, it has a direct impact on cost reduction by eliminating inefficiencies and minimizing the need for reactive maintenance or excess inventory. Operational costs are lowered, which contributes to overall research productivity. So in essence, you can say process optimization with machine learning allows researchers to focus their resources and efforts on core research objectives rather than grappling with operational bottlenecks and inefficiencies. So this not only accelerates the research process, but also enhances the competitiveness and sustainability of organizations across various industries. So as machine learning technology continues to advance, it is expected to play an increasingly pivotal role in process optimization and research across diverse fields. So machine learning's impact extends well beyond these examples, but permeating research is a virtually every discipline. Every discipline. So its adaptability and ability to learn from data make it a versatile tool for uncovering hidden insights, innovative solutions, and driving research forward. So researchers, engineers, technicians are continually exploring novel applications of machine learning to address complex research questions, indicating a dynamic and evolving relationship between AI and research. And now, finally, the next slide, conclusion. Um, in the fast-paced realm of technology, few innovations have had as a profound as impact as artificial intelligence and machine learning. So, as we conclude our exploration into these transformative fields, it becomes evident that their potential knows no bounds. From revolutionizing industries to enhancing everyday experiences, AI and ML have become indispensable tools shaping our future. So, AI. At the heart of AI and ML lies the ability to process vast amounts of data, as we discussed throughout the lecture, with unparalleled speed and accuracy. So this capability has revolutionized fields such as healthcare, finance, manufacturing, and beyond. So in healthcare, AI-driven diagnostics are enabling earlier detection of diseases, leading to more effective treatments and improved patient outcomes. So in finance, ML algorithms are revolutionizing fraud detection, risk assessment, and investment strategies, enhancing both security and profitability. Moreover, AI and ML are not just catalysts for efficiency; they are also driving innovation through techniques like deep learning. Machines, are not only analyzing data but also generating insights and solutions that surpass human capabilities. This innovation extend to field like automation vehicles, where AI is reshaping transportation, and to creative industries like art and music, where ML algorithms are pushing the boundaries of human expression. However, with great power comes great responsibility. As we embrace the potential of AI and ML, we must also address next slide, ethical consideration and mitigate risk. Concerns around bias in algorithms, data privacy, and the impact of employment underscore the need for careful regulation and ethical frameworks. So it is imperative that we prioritize transparency, fairness, and accountability in the development and deployment of AI and ML technologies. Furthermore, the democratization of AI and ML is crucial for ensuring widespread benefits. If efforts to make these technologies accessible to diverse communities and industries must be prioritized. And this through conducting these various webinars on AI and ML, Asia Open RAN Academy is doing this same thing. Through education, training, and resource allocation, we can empower individuals and organizations to leverage AI and ML for positive change. And the journey into world of AI and ML is one of endless possibilities. And from optimizing processes to sparking innovations, these technologies are reshaping our world in profound ways. As we navigate this transformative landscape, let us embrace the potential of AI and ML while remaining vigilant in addressing ethical concerns and fostering inclusivity. By doing so, we can harness the full power of these technologies to create a brighter, more equitable future for all.